Hi guys, this is a calculus video, video 5-14, and this one's to be watched before Monday the 30th. If you fall a little bit behind on the videos, it's not going to kill you, but all of these remaining videos, including 5-13, so all the videos after the midterm, are all on a thing called U substitution, which is an antiderivative technique. So, and I'm going to start giving problems that involve U substitution on Monday. Okay, so watch these remaining videos as fast as you can. And the homework that corresponds to this one is page 22, number 5. Okay, now I wrote this last year, like this stuff for my students last year, so let me read it. U substitution clues, like how do you know that you're going to be using it? And then I said, look for products and quotients that cannot be separated or expanded to use power rule or other known antiderivatives. And definitely look for a composition of functions. So I'm not going to talk about this key observation here. You could read it if you want, but I'm not going to talk about it because I feel like it confused people last year. But this is pretty good, what I wrote up here. So basically, if you can't find the antiderivative using power rule or definitions that you know, then you've got to try to use U substitution. Okay, so down here, we're not even going to find any of these antiderivatives. We're just going to answer this question. Which of the antiderivatives below can be found without U substitution? And we're going to ignore this one. So let's just cross that one off completely. Okay, so which of the antiderivatives can be found without U substitution? So you're looking for ones that you can use power rule for, or like definitions. For example, are known antiderivatives. So like if you are taking the antiderivative of cosine, well, obviously you wouldn't use power rule for that, but you know that the antiderivative of cosine is sine. Okay, so, alrighty. So down here, let's look at this first one. Do we need U substitution? No, we don't, because you could split this up as x to the third over x squared plus 5 over x squared, and then bring everything up to the numerator to just use power rule. So number 1. Okay, number 2, do we need U substitution for this? No, because same, we could just split this up, x to the third over 3 plus 5 over 3, and then we could find the antiderivative. So number 2, we don't need it. Number 3, so you ask yourself, 6 cosine to the third of x times sine of x. This is a very complicated function. We cannot use power rule on it, and we don't know, we have not memorized an antiderivative of this. This is not a function that comes up a lot. So yes, we would need U substitution for this one. All right, so I'm not going to write it up top. This one here. Now this one is kind of iffy because we cannot use power rule on it the way that it's written, but you could expand this out, x to the second plus 5 times itself again, distribute everything, then distribute the x in. So, you know, technically you could use power rule on it if you rewrote it, but I wouldn't recommend it. U substitution actually would be better for this one, so I'm not going to write that one up there. This one here, you cannot use power rule on this. Okay, there's no way of rewriting it in the form of terms a x to the n. Okay, this one here, same, can't do it. This one here, we could actually, if this was just an x inside here and not a 5x, then we would not need U substitution, but because this is a 5x, we can't do it without U substitution. This one also, we would need some technique, maybe U substitution, maybe not. Same with 9, can't use power rule, don't know the antiderivative of this. Number 10, this one would be good because you could just distribute that x squared inside and then use power rule. Okay, so 1, 2, 10, and then this last one here, you could convert this to x to the 5/3, and then you could use power rule. So 1, 2, 10, and 11. These are the ones that can be found without U substitution. Okay, now below, guys, this is a formula. Okay, so let's write this down. We're about to use this. Formula to know. And in the past, I did not ask my students to memorize this. I painted my nails the other day, by the way. I hope it's not distracting. So the other day, or not the other day, the last year I did not have them memorize this. But, okay, if you are finding the antiderivative, remember an empty integral really means antiderivative. In college, sometimes they'll say the integral of, but I'm going to say antiderivative because that's what an integral sign without upper and lower limits means. So if you are taking the antiderivative of a function of this form, then it's going to be equal to the natural log of the absolute value of f of x plus c. Okay? So guys, anytime you're taking the antiderivative of a quotient, we are going to see if we can use this formula. All right? So that's what we're going to do over here. We're actually going to do 3 examples. Okay, so this is going to be example 1. All right, and then I'm going to do 2 more after this. Okay, so I'm taking the antiderivative of this quotient. And by the way, the formula I just introduced is a shortcut for using U substitution. All right, so I'm going to say to myself, if I let the denominator be f of x, and I take its derivative the numerator, 3x squared plus 3, yes it is. So guys, this is actually of the form f prime of x over f of x. And anytime you're taking the antiderivative of a function of the form f prime of x over f of x, then the antiderivative is the natural log of the absolute value of the denominator. And guys, the way that this would work with U substitution is you'd let U be the denominator and then do U substitution, and it would always work out this way. But it's kind of complicated, so I'm just going to ask you to memorize the formula this year. Plus C. So this is the family of functions, all of whose derivative is this function right there. Okay, so there's example number 1. That's a very straightforward one. Example number 2 is going to be less straightforward. It's going to be like this. So we'll do the antiderivative of 5x over x squared plus 1 dx. Okay, so again, I've got a quotient, and we will have in a few days from now more techniques to find the antiderivative of a quotient, but you always want to test this one. So I'm going to always let f of x be the denominator. This only works if the original function is the denominator. Then you take the derivative of it, and that's 2x. So the numerator is not 2x. But guys, we're only off by a constant multiple. Okay, we're only off by a constant multiple. The only difference between 5x and 2x is the coefficients. So if the only difference between the derivative of the denominator and the numerator is a constant multiple, well then you can do you can rewrite this so that you could use the formula. So let me show you how. And in the future, you probably will go faster than this. So first of all, I don't want a 5 as this coefficient. I want a 2 as the coefficient. So the first thing I'll do is I'll use the constant multiple rule, and I'll bring the 5 out in front. And then I've got x over x squared plus 1 dx. So now I just have a regular x, but I want a 2x. If this numerator were a 2x, then this function would be of the form f prime of x over f of x, and then I could use the formula. Well, let me do this trick. I can put, if I multiply the inside by 2, actually let me go a little bit slower. I can go 2 over 2, and I have not changed this at all. Okay, 2 over 2 is 1. Okay, so I have not changed this function at all if I just go 2 over 2. All right, so I do that. And then I could bring this denominator, this 2 in the denominator, I can use the constant multiple rule and bring that out front. So this is 5/2 antiderivative of 2x over x squared plus 1 dx. And now, if you just look at this antiderivative part, we have the denominator is f of x and the numerator is f prime of x. So now this is equal to, just bring down the 5/2 constant multiple rule, and then the antiderivative of this is natural log absolute value of x squared plus 1 plus c. I'm so glad I'm doing it this way this year. Okay, my previous calc students had to do U substitution, and this is a very nice shortcut. Okay, guys, one more. Okay, so this is example number 3. And we will do the antiderivative of x squared over x to the third minus 5. Okay, so same, this is a quotient that we're finding the antiderivative of. So let me see if I can use the formula that I wrote on the other page. So f of x equals always the denominator. F prime of x equals 3x squared. All right, so if this numerator was 3x squared, then I would have it. So I'm only off by a constant multiple. I'm only off by a coefficient, okay? So so I can make this, I could use the same sort of trick, ignore that 5. I can do this trick here. And then just bring the denominator like out in front. But let me show you a little bit faster way to do it than what I did here. So I'm going to do it in 1 step instead of in 2 steps. So I'm going to go like this. I'm going to force this coefficient to be a 3. And then I'm going to balance it out by putting a 1/3 out front. Okay? If you don't like that, if that doesn't make sense to you, then you go 3 over 3 in here, but make sure you have parentheses there, and then bring the 1/3 out front. Okay, but I'm going to do it like that. So now I've got it. This is f of x, that is f prime of x. So this is equal to, bring the 1/3 over, carried over, constant multiple rule, natural log of the absolute value of x to the third minus 5 plus c. It's a c. Okay, guys, so there is that. And the homework is just one example, page 22, number 5. Okay, I will see you soon. Bye-bye.